Welcome to yet another week of Python programming. Let's go through the assignments for this week, starting off with your reading assignments. You have 3 this week. The first one is to read your Starting Out with Python book, Chapter 3, that is Design Structures and Boolean Logic. You also have 2 lessons to read from the Intro to Computing PDF. Lesson 3.3 is about storage devices, and Lesson 3.4 is I/O, or input-output devices. Also, you will have quiz number 1 due on Sunday. So not only do you have a lab this week, you also have a quiz. The quiz is many questions. You're allowed to take it up to 2 times. It's on chapters 1 and 2. Might I suggest you do at least part 1 of the lab before you attempt the quiz? Because lab 3 is all about a chapter 2 review of all the topics. And then coding based on everything we did in that. A reminder, Chapter 2 was input, output, and processing. Chapter 1 is also in the quiz as well. And you might find some questions in there from the Intro to Computing lessons you've been reading as well. So Chapter 2, quiz number 1, due this week on Sunday. Let's talk about the lab. Lab 3. The first thing you want to do is part 1. Submit this, please, as a Word or PDF document only. You will work through all of the checkpoints of Chapter 2. Now, I'm only asking for specific questions, not all of them. If you do more power to you. I'm only grading the ones that are listed here. So, Chapter 2, the checkpoints, just like Part 1 from the previous week's lab. Now, that's worth 20% of your grade. Now, the rest of it is writing 2 distinct Python programs. Both of these are from your book. It's from the end of Chapter 2, the programming exercises. I'm going to ask you for the first one to create a program that solves programming exercise number 8. That is called tip, tax, and total. And it reads like this. Write a program that calculates the total amount of a meal purchased at a restaurant. Your program should ask the user to enter the charge for the food, and then you need to calculate amounts for an 18% tip and 7% sales tax, and then display each of those amounts. So, take input, process input, display output in the form of what the value of the tip is, what the value of the tax is, and what the total bill is. I would highly suggest you look at the software requirements. As we talked about in Chapter 2, every user who is your customer has requirements. Requirements are as follows. Store all of the values that you assign in appropriately named variables and named constants where appropriate. You've got 2 percentage rates you're figuring out. Those are the textbook example of when you would use a named constant. Use comments where appropriate. Your name would be lovely. That would be a great thing to put in there. Also, please, whenever you use a variable, describe the variable. Maybe even describe the processing you're doing and the output that you're doing when you're going to do it via comments. Any data request that you have for a user, basically asking them to input the amount of the bill, should be user-friendly. Use the right prompts, have spacing after your prompt so they don't have their text running on with what you wrote for the prompt. And then format your output, at least in this case, so that all the numerical numbers line up in columns. Nice, neat columns. I talked about that in last week's lecture. If you need to refresh that, go back and watch the video. Here's my hint to you. Use tabs. Part 3 is another program. This is the ingredient adjuster. It's number 10 from the end of the programming exercises in Chapter 2. Basically, you have a cookie recipe that calls for the following ingredients: 1.5 cups of sugar, 1 cup of butter, 2 3/4 cups of flour. You basically, and the recipe produces 48 cookies. You basically write a program that asks the user how many cookies they want to bake, and then translate the number of cups necessary. So, for example, recipe produces 48 cookies. If the user wanted to make 480 cookies, you'd multiply the values of all of the ingredients you'd need by 10. Again, make sure you watch your software requirements. They're all pretty much the same from the previous one. You will save these as Lab 3 Part 2 and Lab 3 Part 3.py respectively. To get full credit, you need to have 3 files submitted. Your Word or PDF document with the checkpoint answers from Chapter 2, Lab 2 Part 2, Lab 3 Part 2.py, and Lab 3 Part 3.py. All 3 of those files submitted together. Again, I would suggest doing that sooner than later, just in case there's issues. So, that's the assignments for the week. Again, do your best, follow the directions, watch the details. Let's talk Chapter 3. Chapter 3 is all about design structures and Boolean logic. What does that mean? Well, we're going to basically cover the if statement, and the if statement has a whole bunch of options to it. If-else, if-elif-else. Part of that is looking at the Boolean logic behind that. If some condition happens, then what do we do with that? And talking about the operations that we can do with that, and how Boolean variables work, and what a Boolean variable is for that matter. So, we're going to start off with the if statement. We're going to talk about control structures. What is a control structure? It's basically the design that you follow that controls the order and how your Python code executes. Okay? So far we've seen very, very simple examples, and we're going to get in more detailed examples, but what we've seen pretty much is what we call sequence structure. All the lines of code that you write get executed in the order that you type them. Decision structure actually affects various actions based on if certain conditions exist. Sometimes those are called selection structure. So when you're planning your software, when you're looking at pseudocode, or more importantly, when you're looking at a flowchart, let's say, we talked about the oval, we talked about the square, we talked about the trapezoid. For conditional statements, or anything that has choices to it, you use a diamond to represent that. Okay? And there's arrows that come off different sides of the diamond that are only performed, again, when the condition is true or false. Some are performed when they're true, others are performed, or others are just skipped if it's not. So something called a single alternative. There's only one choice. It's either true or false. And if that is true, then you go through and you do these statements. And if it's not, you just exit out and go on your merry way. Looks something like this. Okay? Is it cold outside? If it's cold outside, then we should wear a coat. If it's not, then you don't. You just skip the coat right over and you go back to where you were. But as you can see, when the condition goes through of true, it exits out of the little linear that it was in, executes another statement, and then goes on. Now, to say that a single alternative decision has one statement is not necessarily true. It's just saying that there's a single choice, true or nothing, basically, because false would basically mean nothing. So your alternative, if it's true, is to go off the separate path. Now that path could have more than one statement. Cold outside? If it's true, then wear a coat, wear a hat, and wear gloves. If not, you're skipping all those and continuing on. But you do those 3 steps, and then you can go back to where you were. In code, this looks like this. You write if, some condition, and a colon. That's how these go. Conditions in this case can be either true or false. And when the if statement executes, the condition that you write is tested. If it's true, you have some statements that get executed. If not, it's skipped. Now, the statements that you execute, as you can see here, they are kind of aligned off to the side. So we have the if statement out here, and then our condition and the colon, and then the statements for that condition. So if cold outside, first statement would be wear a coat. Next statement might be wear a hat. These are kind of tabbed in. You see they're not in line with the if. They're moved in a little bit, and they're lined up with each other. That's how you know when we have a condition going on. So what's a Boolean expression then? A Boolean expression is basically anything that tests to see if something is true or false. Boolean means choice of 2. So, for example, is A greater than B? If A is greater than B, then it's true. If not, then it's false. The relational operator, basically it's the term that means how you're determining what relationship exists. You have greater than, you have less than, you have equal, you have not equal. Okay? Basically talking about how two things relate to each other. The operators that you use in code look like this. I mean, greater than or less than, same old as math symbols. If something is greater than or equal, is something 10 or more, or greater than or equal to 10. That would be the greater than sign followed by the equal sign right away. Conversely, less than equal to. Okay? Equal is what you use to determine whether something is equal. Does A equal B? We know that we have the equal sign to be an assignment operator. So if we said A equals B in code, that means A is assigned the value of B. But if we say A equal B, that means you're testing to see if A and B are actually equal. And the exclamation point equal sign, sometimes called bang equals, stands for not equal to. Let's see how some of these work really fast here, right? So we have, let's just say A equals 10. We can say print A greater than 1. That would be a condition. True is what it comes back with. Print A less than 1. False. And the same thing will work if we start to do if statements. So let's write a quick program here. A equals 10, B equals 9. We would say if A is greater than or equal to 10, colon, and see how Python automatically puts my cursor over a little bit. Print true, A is greater than or equal to 10. Let's go down here. So I hit my backspace key to go back to the thing. If A equals B, colon, enter, again it tabs me over, print A is equal to B. And let's try if A is not equal to B, print A is not equal to B. And again, very simple thing just to prove or to show how these statements work. I'm going to save this, if test, and then we're going to run it. Change the size of the window a bit so we can watch it go. So, what did we expect to happen here? Is A greater than or equal to 10? Well, it's equal to 10, so true. A is greater than or equal to 10. Is A equal to B? No, it is certainly not. So it skipped that right over. If A is not equal to B, then print this. And sure enough, it said A is not equal to B. So that's how a simple if statement works. You write the if, you write the condition in parentheses, followed by a colon, and you write whatever statement you want it to do. Let's modify this up a little bit. Let's say, let's do this. Let's say if A is, let's move this around. Let's start with this and say if A is not equal to B, then same thing, just different order here. So when I run this, we're going to get true, A is equal to greater than or equal to 10, A is not equal to B, and that's it. Let's do two statements here. Let's say print A. I'll put a tab character in there just because we want things to look nice. B. Save it, run it one more time, and now it's going to show us the value of A and of B. Now, we're now also going to say, let's make A, equal B. Why not? I'm just going to copy this line, just so we have everything there. So what will this do now? This code is going to show us if A is greater than or equal to 10, Great, we're going to print that line. If A is not equal to B, and when we go through here it's not, it's going to say, hey, A is not equal to B. It's going to print out the numbers. Then it's going to reassign A to the value of B. When we come down here, A will then be equal to B, and it should print this out for us. So let's save this and run it, and look at that. None of this should really surprise you as far as reassigning the variables. The if syntax is the only thing that's really new here. So in a flowchart, what does this look like if we put it all together? So let's start by just a simple guess my age game, right? So let's say we're going to set an age variable, and we're going to set that equal to, I don't know, have the computer print out a random number, or pick a random number from 1 to 10. We're going to get the user's guess. Now, does the guess equal the value for the age? If it does, we're going to write, hey, correct. And then we're going to quit out. If it doesn't, we're going to say incorrect. And we can either exit out there, or we can go back, and we'll talk about loops next week. But we can actually go back to a different spot and redo that guess if we needed to. But as you can see, true or false, there's one decision process to go to with that. Here's a recap. This is in chapter 3 of your Python book. Basically, greater than, less than, greater than equal to, less than or equal to, and not equal to. Those are your common expressions and relational operators. Now, this is just for numbers for right now. We'll talk about strings shortly. So, how else can we use this? Well, let's say if our sales are greater than a certain amount, then we're going to get a bonus. Great. If our balance is equal to 0, or if our payment is not equal to balance, these are basically code. The same thing I've just done for you in our example. And it is possible to have another if inside another if. We'll talk about the complexity of that later on. Now let's look at two choices. What if you have a dual alternative? You want one thing to do one thing, and my flowchart there for the game kind of showed that. Two possible paths. If something is true, then we're going to do one set of statements. And if it's false, we're going to do a different set of statements. And if you notice, we have a new word here. So we have if, some condition, then do these statements. And again, that's kind of indented over. Then we come back to underneath the if part, and the spacing here, the columns are very important. Else, colon. What does that mean? That means, well, you know, you've always heard you've heard the phrase before, do this or else. Well, if you didn't do this, else do this. So you pick some other statements in here. Notice the if and the else have to be aligned together. They both get colons. One's after the condition for your if, and one is after your else. And else, if it exists, is the very, very end of your if block of code. So if condition, if A is greater than or equal to 10, then run these statements. Else, which is another way of saying if it's not, then do these other statements. Again, the if and the else must be aligned, and the statements for each one of those expressions must be moved in just a little bit, just to make sure that we have things going in the right direction. So it looks like this. Is the temperature less than 40? If so, then on the right there, if so, then print, it's a little cold, isn't it? Else, or false, print, hey, nice weather we're having. Two alternatives there. So your block can look like this. So again, if, condition, colon, and then indented a bit, a bunch of statements, then come back out and say else, statement, statement, statement. Now, if you actually do the if condition, if that condition is true and you perform all of these statements in here, then after it's done, it ignores everything for the else, and your program continues on from down here. So all of this would get ignored because it doesn't meet that condition. Conversely, if your condition is false, it's going to ignore all of these and go immediately to the else. And when it's done with those else statements, it's going to continue on where it left off, where the end of the else block is. Again, strings to compare operators to compare things are very similar. Strings are an interesting character. You can actually use equals equals and not equals to compare strings. Those make sense. What might not be so clear is using strings to compare greater than or less than. So how does that work? I mean, does this string equal this string? Is it the same or is it not the same? That makes sense, common sense. Well, greater than and less than, that goes back to our ASCII codes. If you recall, you had to do for one of your questions, printing out your name in ASCII, looking up the value, and using those numbers to throw these letters out there. And the capitals started at capital A at 65, and lowercase a starting at 97, and a bunch of things in between. Same kind of concept here. If you compare strings using an if statement, then it will compare the ASCII values of all the characters. So Mary and Mark are very close, but Mary is a little bit larger because the numbers are higher. So, what if you have more than one condition? If or else. But what if you have if two things? If the weather is so much and something else. Or, in this case, to get a loan, you must make $30,000 a year or more and have had a job for at least 2 years. All right, at least is the same as greater than or equal. You need to make at least $30,000 a year or more, equal to $30,000 or more, greater than or equal. Same thing with at least 2 years. Number of years you've employed has to equal 2 or more. So, how do we do this? Well, we do nested if statements. So, looks kind of like this in the flowchart part of it. If your salary is greater than or equal to 30,000, you come along that right-hand path there. So, if it is true, come down here. Now you have another if. If years in the job is greater than or equal to 2, hey, you qualify for a loan. If not, then you have to be employed for at least 2 years. Same thing back up here. Is your salary greater than or equal to 30,000? If not, you're immediately out and you don't even see this block over here. You go right out and say, hey, you must have at least this much money per year, and it comes out here. Same kind of concept there. If one, then if another. And you can use this. The most common use of this is determining grades, actually. It's a neat little concept. It's really important. Can't say it enough that your indentation must look correct. Okay? When you're writing this code, this is one more way of paying attention to minor details. Don't forget your colon after your condition, and don't forget your statements to be tabbed in, otherwise somehow aligned in with each other. And then when you come back out again, that's either for your else or the next line of your code. There is one more statement we're going to talk about, the elif statement. And this is kind of a special version of your multiple if statements. So you can say things like, if this one condition, no, well then if this other condition, well if this other condition, and if all else fails, here. Give you an example. If today is Monday, then today's not Monday, okay. Else if today is Tuesday, no. Else if today is Wednesday. Else if today is Thursday. Else if today is Friday. Else it must be the weekend. That's where you'd use that. So elif is kind of a special case else that has a condition in there too. Is your grade 90 or higher? Do this statement, you get an A. Else, if your grade is 80 or higher, well, 80 to 89 really, because we've already missed the 90 part, then you get a B. Else, if your grade is 70 or higher, do these statements, you get a C. Else, if your grade is 60 or higher, then it's a D. Else, anything else, you fail. You can put as many elif statements and clauses and the statements in there as necessary but you always end if and elif with an else. There's always have to be that else. So let's look at what it looks like. It looks something like this. If your score is greater than or equal to 90, you get an A. Else if you get 80 or better, you're B. Else if 70 or better, C. Else if 60 or better, D. Else you rate as an F. This is how the flowchart for something like that nested if-elif-else looks. All right, more operators that we can use. What if you're testing two things? I want to know if you make your 30,000 or greater and if you've been employed for 2 years together at the same time. You can do that. There is 3 different what we call logical operators to create more complex Boolean values. And or, they're basically connected to expressions. So if something and something are both true, then the whole statement, the whole condition is true. If something or something, 2 conditions, one or the other is true, then the whole condition is true. Not is what you'd expect. It's just the opposite. So you can say, if you don't make 30,000 or more. And yes, you can flip that around. There's times where not becomes actually appropriate. Okay, so let's look a little more deeply at and. It takes 2 expressions. Okay, again, we make 30,000 or more, greater than or equal to 30,000, and greater than or equal to 2 for our years. If we're saying and, they both have to be true, well then, true and true is the only way you get true. If one of these is false, then the whole condition of both of those being put together with an and statement and operator is false. Again, on the other hand, if you have an or, if we only needed one, you have to be employed for 2 years or 30,000 or more, if that were what we were looking for, then only one of those has to be true for the whole condition to be true. And if they're both false, then there's no way the whole condition can be false. So it can be true. So for and, the only way it's true is if they're both true. For or, the only way it's false is if they're both false. Python also does something that they call short circuit evaluation. Basically, it reads the 2 in order. If the first one for an or is true, well then the whole compound statement is obviously true, because only one has to be for the or operator to be true. For an and, if the first one is false, well then it doesn't really matter, because the second one, it doesn't matter if you read the second one or not, because if one is false, the whole statement is false. It short circuit. It's just to save time, save processing cycles. It only has to read the first one, depending on the operator, to know. So again, the not operator, it just changes it around. So if you say not equal, I said that earlier, not equal to 10, or not equal, I think it was A is not equal to B. Okay? You could also use the word not when you're combining things together. So here's some examples. X is greater than or equal to 10, and X is less than or equal to 20. You'd use that to figure out if a number was between 10 and 20 inclusively. Is the number between 10 and 20? Well, is X greater than or equal to 10, and at the same time, less than or equal to 20? It's got to be in that range. Those two values together. On the other hand, if you're saying any number except 10 to 20, then you'd say any number less than 10 or greater than 20, because you can't have a number that's both less than 10 and greater than 20. That doesn't make sense. So there's your or. Referencing 2 values, if it's true or false. It's represented by the Boolean data type. So we've talked about floats, which are decimal points. We've talked about ints, which are whole numbers. Okay? A Boolean, is basically one that says true or false. So you can use these neat little, they call them flags. I will set this program to do something when a certain condition is true or false. If you're looking to see when something stops, you set a variable. You can actually set a variable to be true or false. Again, they're called Boolean variables. And so you can set for when this condition happens, maybe it's not something you need output for. Maybe it's not a mathematical operation. Maybe you need to worry about if you are on so many lives when you're writing a video game, or if you've hit a certain level, or if you've gone past so many points. And once you hit something, set a flag. And so the next time something comes around, you play a different sequence. So let's say every time you lose a life, well, extra lives equals one less than you were before. If extra lives equals 0, you're on your last life of a video game, then you say play end sequence equals true. So now let's say the dying sequence, when you get whatever to cause your character to lose its life, the first check you can say is, hey, is the play the ending sequence, play the game over sequence set to true? No? Well, we'll just keep going and iterate this set of commands, set of statements that says just take life away. But if it is set to true, then we're going to go over here and execute the game over signal. It's a flag. Look for something that you set, and you can stop that process. This will make a lot more sense when we start talking about loops and other decision cycles like that. Know that it's called a flag, and you set it and check against it to make something happen at a certain point in time. And again, we will cover this in greater detail. That's pretty much it on the lecture part of it and what is an if statement. What I would like to do, though, real fast, is kind of show you a quick example. Let's talk about an if statement. Let's bring this up here. We'll say new file. It'll look something like this. I mentioned before, let's say if we're on a day of the week. So let's just say we're going to write a program that tells what day of the week it is. Okay, so let's just say we'll say day is an input. We're going to cast this as an integer because I want them to be numbers. We're going to tell the user to enter a number from 1 to 7. Close that off. Let's be a little more nice about it. Prompt should be user friendly. Representing the day of the week. Space. That looks a little better. Close off the int. Now, again, reminder from last week. If we're doing an input, inputs are always strings. What I want is the user to enter a number. So I will have to cast this to a number. So the input command takes in a string. Even if it's 1 or 3 or 7, it's still going to be marked as a string. So I'm telling day not just to be equal the input, but to be equal casting to an integer. We did this last week as well. You will need it for your lab, for lab 3. So be aware of this. So day equals cast as an int the input for this. Now we'll do a big bunch of if statements. If day is equal to 1, then we'll just be clean about our code here. Then print Monday. Elif day equals 2, print Tuesday. We'll just keep writing this out here. I'll be consistent. Look at that. See, being clean about your code is something that I will be looking at. Maybe not for these first few labs, but readability is very important. Elif day equals 4. We're getting there. Print Friday. And let's end this early here and say else. Print it is the weekend. All right, let's save this day, and let's give it a quick run here. enter a number from 1 to 7, representing the day of the week. Let's say 3. It is Wednesday. Great. Let's bring this up here. Let's try this again. Run it again. Let's say it's 7. That should be a Sunday. It is the weekend. Look at that. But here's an interesting thing. What happens now if I run this and I say 8? It is the weekend. Well, why did that happen? Well, because I didn't go. I thought I'd be lazy and say, well, if it's not Monday, Tuesday, Wednesday, Thursday, or Friday, it's got to be the weekend, right? So let's try this. Let's try elif day, let's see, day equals 6. I'm going to clean up my code up here while I'm at it. Day equals 6, or day equals 7. We will print it is the weekend. But what about our else? Well, our else now needs to say, Tom, learn how to select your data. Needs to say, that is not a value between 1 and 7. This is a process that we call in programming sanitizing your inputs. Or at least, maybe this is not so much sanitizing, but this is error checking. When you check, you're checking to make sure that the user inputted what you were expecting to process with. Let's just say that we can't expect people to do what we ask them to do all the time. I would dare say Lab 1 and Lab 2, for some people, were an indication of that. However, if we're saying put in 1 through 7, and somebody puts in a number that's not 1 through 7, we need to account for that somehow, or our program looks dumb. If I type in day 8 and it says, hey, it's the weekend, nope, it's not a day of the week. There are not 8 days a week, despite what the Beatles tried to tell us. So, we're going to hit save here. Let's slide this out of the way a bit. Oops, we can't. We're going to run this. Invalid syntax. What did I mess up? An or, because it's case sensitive. Save that again. And now we'll run it. And now, okay, let's try 1. Let's try this again. 1. Wow, I'm really having a problem with my keyboard today. 1. Monday. There we go. Run it again. Now let's say 6. 6 or 7 should be the weekend. Let's run it one more time. 7. It is the weekend. But now let's run it one more time and try our 8. That is not a value between 1 and 7. So that is how it looks when you start checking for invalid inputs. And understanding that just because you ask the user to do something doesn't mean that they will do it. And so you have to account for that. So there's a good example of an if statement, along with elif, along with where you would use else, along with how you would use or, and the overall concept of what it means to check for errors in what the user is putting in. If you're asking somebody to enter data, don't presume that they're going to give you what you asked for. That's it for the week, for this week. As usual, if you have questions, please go to the Q&A discussion forum or send me an email and we'll set up some virtual office hours. See you next week.